All right, so let's look first at let's look at the first set of problems there. I'll pick one that's kind of weird. Let's see. Let's look at number. Let's start off with something a little simpler just before we get into anything, something real complicated, just so you don't think, oh my gosh, they're all this hard. So let's look at number 3. Is that showing up? Yeah. Okay, so secant theta is the square root of 2. They tell us, and then sine theta is negative square root of 2 over 2. And what they want us to do is use the given values to evaluate, if possible, all 6 trig functions. So we've got the secant and we got the sine.
So those are both from the
same problem, okay? So they're both describing the same angle. And we've already got 2, and don't we really easily have 4 of them? Because all we got to do is flip them, and we'll have another set. For instance, what's the reciprocal of secant? Cosine. Okay, so the cosine is going to be 1 over square root of 2, and we got to rationalize it. Yeah. Okay, so it's the square root of 2 over 2 is the cosine, and the sine, we got it's a negative square root of 2 over 2. So what's the reciprocal of it?
Just same thing.
1 over square root of 2? I mean negative.
Well, what's the reciprocal of sine?
I'm getting the same thing because you just flip.
I'm just thinking I'm looking for cosecant. Cosecant. Okay, so cosecant.
Oh.
Yeah, I'm sorry. You're right. Yeah. Yeah. Didn't this used to be negative 1 over square root of 2, and somebody rationalized it for us already, which sometimes is not so helpful when we have to go flip it. So if it used to be negative 1 over square root of 2, it would be negative square root of 2, right? And that's what y'all were saying, right? Okay, yeah. So we were both getting at 2 different things of the same. Yeah, you were just answering the different part than I was thinking. So we're all on the same page here. All right, so now the only ones I got left are cotangent and tangent. How can I find the tangent easily? Yeah, it's just the sine over cosine. That's one of our very first identities. So we got sine is negative square root of 2 over 2, and cosine was square root of 2 over 2. So that's just what? Negative 1. Yeah. So that mess looks horrible, but it's just negative 1. So what's the cotangent going to be? It was a negative 1 over 1. I'm going to flip it. It's still negative 1, right? So it's the same thing. So sometimes that just happens. Okay. So we did all of those 6 things, and all we did was use the information they gave us. So if you notice, if you look at the numbers on these problems, what's going on is they're either going to be giving you a 30, 60, 90, 45, 45, 90 kind of thing, or maybe it's a triple. If you look at number 5, don't you see those triple numbers in number 5? 7, 24, 25, that's a triple. 7 is 8, 15, 17, so there's a triple. Let's look at number 9 because it looks nasty. So I don't want to. Sometimes you don't want to start with a hard one because it makes it seem like it's impossible to do, but we definitely don't want to leave the hard ones just for home. Okay, so it's negative 2 square roots of 5 over 5, and I'm trying to find all my trig functions. Looking at that, just since I wrote it down, negative 2 square roots of 5 over 5, what do you think that was before somebody rationalized it? Because that's often helpful to think about. Wouldn't that have been negative 2 over the square root of 5? And somebody came in, they multiplied by the square root of 5 over square root of 5, right? And that's how they got that value? Okay, so if I think of it that way, if I kind of look at how could I unrationalize that, if we could kind of get that in our head, it might make it easier to deal with this. What would the cotangent be if I'm just going to flip that? Yeah, and it's negative still, so we'll put negative square root of 5 over 2. So there's one of our values. Let's look at sine. Sine of negative, why in the world did they tell us the sine of negative x and the tangent of x? What do you think they're trying to get us to remember here? Odd and even functions, right? So what were the only even functions, the ones where it didn't matter whether you had a negative x or x in there? Cosine was the only one where I could say the cosine of x is equal to the cosine of negative x, right? This is not one of them. So if I got sine of negative x, sine of x, wouldn't that be, this is an odd function, it just means we take the negative of that number to get the sine of the real x, not the negative x, if that makes sense. So sine of x is really 2/3. So what, if I flip that, I'm going to get 3/2. What function would that be? Cosecant. So if you don't know your reciprocals, you're kind of going to struggle. Yeah, a lot, yeah. This is like last year, this was one of their main problems. I don't think they ever quite got down the reciprocal thing. And if you can get that down, it's not that hard. It's just you got to do it, right? And so if you remember, the S and the C always kind of couple up for a function and its reciprocal. I think that helps make this a little easier. So we've got the tangent, they gave it to us. We got the sine. We actually probably wanted to find the sine of x since we have the tangent of x over here. Got the cosecant. What are we missing? Cosine, and then its reciprocal. How am I going to find the cosine here? Got any ideas?
Wasn't it like tangent sine over cosine?
Yeah, tangent would be sine over cosine, so we could say cosine. Let's think about that. Tangent is sine. I'm just going to leave the little theta off of it to make it faster to write. So if I want to solve for cosine, let's see, if I were to use it, I could just do this algebraically, right? I could put tangent over 1 times sine x is equal to cosine x, tangent x. If I want to find out what cosine is, I could just say, well, let's just divide both sides by tangent x. Oh, cosine would be sine over tangent. And we got those values, don't we? Okay, that's one way I could do it. So let's do it that way, then we'll talk about maybe another way if you're like, oh, I wouldn't have thought to do that. So if it's sine divided by tangent, that's 2/3. And what's the tangent value? Let's see, we wrote, it was -2 squared roots of 5 over 5. Let's do -2 over square root of 5. That's what we kind of figured out it was when we unrationalized it. Let's try that and see how that works. I think that's going to work better for us here. So I'm going to use this value that we figured out here instead of the one they gave us. So it's -2 over square root of 5. Okay, so if I get that, remember it's the numerator times the reciprocal of the denominator when I try to simplify that fraction. So it's square root of 5 over 2. Mine will probably go off in a minute. As long as you don't... Okay, getting back to trig. If I'm simplifying this, I'm going to cancel the 2's out, and the cosine is going to be negative square root of 5 over 3. Okay, that worked out well. Everybody okay with the fraction? Numerator times the reciprocal of the denominator. It's been a while since we've had to do that stuff until this year. All right, so now I need the secant. So that's just going to be flipping that, except that's not going to be very pretty. Let me kind of carve a space out here in the middle to do it so we can look at all the values together. The secant of the angle is -3 over square root of 5 if I flip it, but that's not rationalized.
Square root of 5 over 5.
It'd be -3 square roots of 5 over 5. Okay. I'm going to hit it now. I don't quite know what they're getting at here yet, but maybe if I write that on my paper, it'll help me. Where would the sign be negative?
In 3 and 4.
Okay. So they're telling me my angle, whatever it is in these two quadrants, because everything's positive in the first quadrant, sine's positive in the second quadrant. It must be that my angle is going to be down here. And I'm probably going to need to know that for some reason, though we don't know what it might be yet. We may never know, but we're going to try. All right, so what's the easy one to get here? Or cotangent, right?
Yeah, that too.
The opposite, yeah.
It's easy too, 'cause it's right.
Yeah, it's written for us. That was the easiest one. Cotangent is 1/2. Okay, so what do you think I'm going to do if I just have these two values? I don't know how to split this up, or do I? Have y'all got an idea what we could do here? What if, just because I'm desperate and I'm stuck and I don't know what to do, I draw a right triangle, and I label the angle, and I say, okay, if I'm going to think of this as tangent, let me think of it as 2 over 1, just to have a fraction there, because the tangent is also the opposite over the adjacent, isn't it? Going way back to SOHCAHTOA. And so let me do this. What if I came in and I said the opposite side is 2 and the adjacent side is 1? What would the hypotenuse be? How can I find it? Or you'd think it's actually square root of 5, I think. Yeah, 1 squared plus is 1, 2 squared is 4, 1 plus 4 is 5, square root of 5, right? So it'd be square root of 5 if we do the Pythagorean theorem, okay? So now, could I figure the rest of them out pretty easily? Yeah, I can do this. So this is always a little trick you can do, is if you know what the SOHCAHTOA ratio is take it, and if you got a whole number, stick it over 1, because all we're talking about here are proportions of the sides. When they're doing these trig ratios, it's kind of like similar triangles. We don't know if that triangle is this big or this big, but we do know that the angles have the same ratios. So I can split this up, and I would know that it would reduce down to these numbers, even if the numbers were a lot bigger. So if I want to know the cosine now, we'll start with cosine, I guess, just because it is the word that came out of my mouth. SOHCAHTOA, so it's adjacent over hypotenuse. That would be, bless you, 1 over, bless you, square root of 5, right? Because adjacent over hypotenuse would be 1 over square root of 5, and if I rationalize it, it is square root of 5 over 5. If I didn't, y'all tell me if I mess up. Okay, so the inverse of cosine is secant. So I just need to flip the fraction. Wouldn't it be easier to go back to this one and flip it? So it's going to be square root of 5 over 1, which is square root of 5. So sometimes backtracking a little bit helps on some of these. And all we got to do now is sine, and though I could go say sine is cosine divided by tangent, I could also go to my little right triangle over here, which is the other way that I kind of alluded to earlier. Remember how we said, well, we could take tangent and divide it by something to find the other one? I think you had said that.
Yeah.
Or earlier. This is another way I can do it, is to draw the right triangle and figure out the missing side, and I can make all the proportions really quickly. Sine is opposite over hypotenuse. Okay, so it's, did I miss that?
No.
Opposite over hypotenuse,
I was
right?
thinking opposite over adjacent.
Okay, so square root of 5 over square root of 5 is 2 square root of 5 over 5. Okay, but if I want to find the reciprocal, which is
The
cosecant, I'm going to come back here, because that's, if I flip it, I don't have to think about what I did to rationalize it, right? I just go back, and that would be square root of 5 over 2. Did I ever really, now here's the thing, do I need to adjust any of these values with a negative because of the quadrants they're in?
hope not.
Yeah.
I probably do. Let me turn this off while we